Hello everyone, we have come to the end of the last part of this worksheet. We're going to start with energy part 2. Now, question 1. Which activity has no change in both kinetic and potential energy? Now, if there is a change in kinetic energy, that means the speed must change, right? The triangle sign stands for change. If there's a change in potential energy, it could be that there is a change in height, or perhaps you press a elastic object or you extend an elastic object. So if you look at the options over here, A would be an obvious choice because by standing at the edge of the pool, this lady is not getting higher, lower. The height remains the same, so the GPE is the same, and she's not moving, no change in speed. So there's no change in kinetic energy as well. But for option B, when you bounce on a springboard, the word spring will tell you that when you are bouncing, there is a change in elastic potential energy. So besides gravitational potential energy, do note that there is also elastic potential energy. And for C and D, the jumping and all that, there will be a change in speed and a change in height. Question 2. This book is dropped from a height. Now, when the book is dropping, the book's gravitational potential energy decreases, and that is because the height of the book decreases, right? Remember, gravitational potential energy depends on the height. At the same time, we also know that the kinetic energy of the book increases when it is dropping, and the reason is because the speed increases. So why does the speed increase? Well, anything that is dropping on Earth, because of gravity, the speed will get faster and faster. So although the GPE and KE changes, but one thing you need to note is that at any point, whether it's X, whether it's Y, or whether it's Z, the GPE amount plus the KE amount will be a constant number. So this number is what we call the total energy. Now, this energy does not change. So, a certain part of the journey, for example, at X, you will have a lot more, you will have GPE. Before you drop the book, there will be no KE. Then the GPE converts to KE, and at Z, there will be no more GPE and only kinetic energy just before it touches the ground. So there will be an exchange, there will be a conversion of energy, but the total amount remains the same because remember, conservation of energy, principles of conservation of energy states that energy cannot be created or destroyed. So D is the correct answer here, that the book has the same amount of energy, okay? And this energy refers to the sum of the two together. Let's move on to question 3. The cyclist is traveling down a hill without pedaling, and at point point Y, the cyclist applies his brakes. Remember, when you apply your brakes, the wheels are no longer able to rotate, so you are kind of dragging the wheels on the floor. So that kind of action, you find that you experience a lot of friction, and when you try to overcome friction, heat is produced. Okay, so heat is produced. So from X to Y, it is going downwards, and all downward motion, the energy conversion is from gravitational potential to kinetic. And then at point Y, when you apply the brakes, you have to overcome friction and then heat will be generated. So D is the answer for question 3.
For question 4, the load is being carried upwards by a crane and the distance is not given directly. The speed is given as 1.5. Now, the word here that they use is velocity. Now, velocity and speed at this in lower set, you can take them to be the same. Although when you go to set 3, you will notice that they are actually different, not exactly the same, but at this point, let's take velocity to be the same as speed. So the speed will be 1.5 meters per second. So we can use this to calculate the distance moved. Since the crane is being moved for 10 seconds, so speed times time. So you get 15 meters. And then when you multiply by the force, you will be able to get the work done, which is 8,100 joules. And next,
Question 5. This boy is playing on a slide, so he climbed up the steps. I want you to note the word constant speed. So he climbed up with a constant speed to reach the top, and then he slides down. Another word that I want you to take note is the word smooth, because the smooth slide indicate that there is no friction. So once you see the word smooth, you can assume that there's no friction. That means there's no energy that's lost as heat. So when the boy is sliding downwards, the energy conversion will be from gravitational potential energy to kinetic energy. So this is the energy conversion whenever an object moves down and there is no friction to overcome in the ideal case. So question 5a, so what energy does the boy gain when you climb up the stairs? The answer is gravitational potential energy, since the formula to calculate is mgh, right? So when you climb up the steps, your h increases, so therefore GPE increases. For B, so what energy did the boy lose as he climbed up the stairs? Well, one of the common mistake that students make in this question is they will put kinetic energy, because they assume that when GPE increases, kinetic energy will decrease. So take note that this may not happen all the time. Now, the case where, maybe I'll just draw a diagram. So if you have a ball that's dropping on its own, of course, in this case, you can say that GPE decreases, KE increases, because this ball is free to just fall on its own. But in this case, the boy is exerting energy to climb up, so it is not an object that is being thrown up on its own. So this, in this case, this may not happen. All right. And of course, we also know that in the question, the boy is moving with a constant speed. So constant speed means that the kinetic energy is constant. So there will be no gain or loss of kinetic energy. So what is it that the boy, what energy did the boy lose? Well, in order to be able to climb up the stairs, the boy must have energy to do that. So where does the energy come from? The energy comes from the food that he eats. So during respiration, the body will give out energy from the food and provide the body with the energy to do work. So as you're climbing up, you're using the chemical potential energy from the food. So that gets lesser and lesser. So this is the energy that the boy loses. What is the energy conversion when the boy slides down the slide? Well, it will be quite helpful if you can remember that downward motion, usually you will be from GPE to KE. D,
for 5D, the girl has a smaller mass and she climbs up the same flight of steps with a faster speed. So there are two things that are different right now. The mass of this person is smaller, of the girl is smaller, but the girl is moving with a faster speed. And you are asked to compare the gravitational potential energy gained as compared to the boy. Now, because in this case, with a smaller mass, this GPE is mgh. So with a smaller mass, the GPE gain will be smaller, because whether it's the girl or the boy, the gravitational field strength G and the height is the same, because it's the same set of slides that we're talking about. So once the mass is smaller, the GPE will be smaller. The question only asks you to state. So actually, you could just stop your answer here. The rest of the answers are actually explanation for your reference, but you do not need to write it down because the question did not ask you to explain. Now, for D part 2, there's a error in the question because the question asks you to compare now the kinetic energy. This is when it starts to get a little bit more complicated, because kinetic energy is half mv square. So although the mass of the girl is smaller, but the speed is bigger. The question, however, did not tell you how much bigger or how much smaller the values are. So it's difficult for you to make a comparison because one of them goes down and the other one goes up. So it's hard for you to determine what is the change in the kinetic energy. So there will be no answer in this part here. So sorry for the error in the question. Let's go on to question 6. Now in question 6, the box is being pulled by a force using a string. if you're applying a force using a string, a spring, a rope, then the force that's present in that string and rope is called the tension, right? And the box is moving to the right, so the friction in this case should be acting to the left. This is information that you need from the previous chapter on forces. So this free body diagram, do note that for friction, you have to draw between the two um, surfaces. You can also draw it like that if you want. And because this object is placed on surface, so it's touching, right? It's in contact with the surface, so there will be normal contact force. As long as two objects touch each other, there will be normal contact force. And then the weight, which is gravitational force, it will be acting downwards from the middle of the object. I think this case, the middle is, I think the gravitational force should be a little bit more to the right. So if you're not sure where to draw the gravitational force, you could draw a diagonal like that, okay? And then the point where it meet intersect, so that would be the middle. So that's how you can draw. So all the forces are drawn here, and you're asked to calculate the work done by the man on the box. There are four forces. So which one will you use? Now, the question says the work done by the man. So how much force did the man exert? The man is actually pulling with a force of 20 newtons. So therefore, I'll take 20 multiplied by the distance moved. Let's go on to question 7. Now, question 7, the toy car is rolling down the slope. Remember, for any object that's able to roll down freely or drop freely, the energy conversion is always from GPE to KE. So in this case, the question asks for the amount of gravitational potential energy at A. So the formula is mgh. And do note that the mass has to be converted to kilogram because this is in grams. And the slope height is 20 centimeters, which has to be converted to meters as well. So then we will be able to get 1.5 joules as the answer. Then part B, the speed of the car is given and you're asked to calculate the kinetic energy. So again, the formula of half mv square is used, and do note that again the mass has to be converted and you should get 1.01 joules as the answer. For 7C, other than the kinetic energy, one other energy. Let's go on to question 8. Now, for question 8, this boy shoots out a bullet from a Nerf gun. So the kinetic energy of the bullet, do take note that this bullet is only 5 grams. So there are two mass that is given. One is for the gun, one is for the bullet. So don't use the wrong value. Convert 5 grams, of course, to kilograms. And then you will get 0.194 joules as the kinetic energy of the bullet. And when the Nerf gun shoots the bullet upwards towards the sky, the maximum height is 3.5 meters. So the GPE gained when it's at 3.5 meters above the ground will be mgh. Again, this is in converted to kilograms. Then you get 0.175 joules. So what is the kinetic energy? Well, the kinetic energy has to be zero because when you shoot up, so when the Nerf gun shoots out a bullet, the bullet goes up, but when it reaches the highest point, it will actually stop momentarily. There's a moment that it stopped before it changes its path to come downwards. So at that point, at the highest point, it actually stopped moving. So the speed equals to 0. So when the speed is 0, half mv squared, right? So the v is 0, the ke will be 0. So the answer for kinetic energy is 0. And to operate this Nerf gun, the spring is being compressed. So if you look carefully, you can see some springs over here and it is being compressed. So the elastic potential energy is triggered. Sorry, when the trigger is pressed, the elastic potential energy will be released. So that will shoot out the bullet. So elastic potential energy because you're compressing the spring, releasing the compressed spring, and then Ke because the bullet will be shot out of the gun. So that's the end of the worksheet.